this our lab is main lab called Human Haptics Robotics and Condition Monitoring Lab, where Human Haptics Robotics is in the NED and we are having condition monitoring lab here. And this condition monitoring lab, we are having two major components. One is the railway infrastructure conditioning monitoring and other is the railway rolling component condition monitoring.
Main idea of the center is to develop prototypes and day-to-day solutions for the industries that we are facing in terms of the asset performance, asset condition monitoring system. And the main aim of our lab is to develop skilled labor, skilled staff and skilled people who can really look into the industrial problems which are related to the condition monitoring of the assets of different industrial products.
I've been working on railway track condition monitoring. We have been developing a lot of prototypes and devices. I have also registered one patent which is regarding novel rail shoe design, and we've been working on several papers. Our recent publication is of 9.95 impact factor, which was published in IEEE Journal of IoT. And right now we are developing wirelessly controlled TRVs, and we have been developing and diagnosing different railway track problems using IRT, ultrasonic flaw detection.
Up till now, we have worked upon different on-board condition monitoring systems, which include an addition estimation methods, which we did by two different techniques. Initially, we did it by extended Kalman filter, and later on, we worked on generative adversarial networks for addition estimation. We have tried to shift our focus from on-board monitoring systems to wayside systems now, since it is more cost-effective in terms of Pakistan Railway, where manual inspection is still the method to go for inspections.
As we all know that train is considered as the safe and economical and reliable source of transportation across the globe. The purpose of this center and this lab is basically to improve the overall infrastructure of rail or train transportation. My work, the research work that I am doing, is basically fault diagnosis of railway wheel set by using deep learning.
I am collaborating with NCRA lab on a topic, the condition monitoring of overhead line insulators using deep learning, in which we are developing a system, an intelligent system which can monitor and detect the faulty insulators over the transmission lines. We know that the transmission lines are prone to fault, and major fault is the insulation failure. The insulation failures are related with the disc insulators, so here we are developing an intelligent system which will be detecting the faults in the insulators so that we can maintain the lines before the inception of the fault.
Pakistan Railway provided us auxiliary railway track. We have developed smart TRV and we have got also good testing equipment. We have got this sonar test equipment. So we can validate our results and all these things. Most of our research work has been published in IEEE transactions, IoT, IEEE transactions and other railway conferences.
Similarly, we are also focusing on the wind turbine projects. We are looking after different parameters of wind turbine performance and what are the factors which affects the wind turbine. And based on that, we are trying to develop prototype solutions which can be developed indigenously, and once we just produce the prototypes, these prototypes can be used for further production on mass production basis from the industry of the country. This will ultimately have an impact on the economy of the government of Pakistan, of our beloved country, and once we are self-sufficient and looking after all these solutions indigenously, we will not be dependent on the industrial products which are basically we are importing from different countries of the world.
We have been working with our close allies, which is China Instrumentation and Company, and we have been developing through this medium polymer operated optical fiber, which is made up of plastic, and it is almost 5 times less pricier than the traditional optical fiber. And with our collaborators like Pakistan Railways, we are assured that in near future we will be developing and introducing new standards to the railway standards of Pakistan. We aim at reducing railway accidents. Unfortunately, in the year 2019, there were around 100 railway accidents. Most of them were due to derailment. So whatever we are doing is basically to mitigate this problem, these issues, so that there would be minimum loss of lives and countless assets.
We have also worked upon different visual inspection systems, and we have also worked upon traction motor condition monitoring systems. We have developed 2 versions of that. First one is called MFIT 4, which can detect about 36 different type of bearing faults, and since 90% of the faults in rotating machinery in the industry is bearing faults, so that's why we have focused on bearing faults condition monitoring systems. And we have also developed a second version of that, which is called MFIT 4.1, which would be a basic data acquisition system which could be monitored at a remote location, and its parameters could be later identified and analyzed to detect various types of fault and estimate its useful remaining life.
Several PhD students are registered, as well as you will listen some of the masters who have completed their projects, some research associates, they have done their work, and we will be covering all those aspects. I think it has got big support for railway asset conditioning monitoring.